Okay, these are notes 4.2. Three things we're going to talk about. Give a probability model. So basically just basic probability. What is it? We're going to use the complement rule to find probabilities, and also use the addition rule for multiple mutually exclusive events. Okay? So first thing we're going to talk about is probability and sample space. Okay? Probability is defined, okay, this is how we find it, is the number of outcomes of a certain event happening divided by the total number of outcomes, okay, which is called our sample space. So if I think about rolling two die, okay, if I roll these two die, what are the possible outcomes I could have? Okay, well, I could have a 1 and a 1, I could have a 1 and a 1, I could have a 1 and a 2, I could have a 1 and a 3, I could have a 1 and a 4, right? I could keep going. So then a 1 and a 5 and a 1 and a 6. Now, this one could also be a 1, a 2, so 2 and a 1 and a 2 and a 2, etc. So there would be a total of 36 different possible outcomes here. Okay, one way to figure out the number of outcomes is this. If you think about that first die, there's 6 different outcomes, and the second die, there's also 6 different outcomes. So if you multiply this together, there's 36 different outcomes. Okay, so that's our sample space. Our sample space is all possible outcomes. Okay, now to find the probability, we will need to use that other formula. Okay, so in this case, let's find the probability that actually I'll do it like this. Event A is that the sum is equal to 5. Okay, so the probability of event A happening, okay, we said there was a total of 36 different possibilities. How many of them have a sum of 5? Okay, well, 1 and a 4, a 2 and a 3, a 3 and a 2, and a 4 and a 1. So 4 out of those 36 have a sum of 5. So if you reduce that, it's 1 out of 9. So we have a 1 out of 9 chance, a probability of when I roll this, it's going to be a sum of 5. Okay? So let's go to another example. Let's say I have three coins. Okay? How many different possible outcomes are there? Okay, so I could have tail, 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 head, tail, 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 head, tail, 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 head, head, tail, tail, head, tail, head, 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 tail, 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 tail. Okay, so there's 8. There would be 8 different outcomes. Okay, and you can think of it this way. Okay, how many? The first one, there are 2 outcomes: head or tails. Head or tails, head or tails. 2 times 2 times 2 is 8. So there would be 8 different outcomes. How many of them would be exactly 2 heads? So I could have 2 heads there. I could have 2 heads there. I could have 2 heads there. So we'd have 3 different outcomes. So the probability of A would be 3 out of 8. Okay? Okay, the next idea is the complement. Okay, so this isn't a compliment like you have very nice hair or something like that, okay? This is a complement rule that says we use the notation like this. The complement of is that a probability event does not happen. So in this one right here, the probability that A complement, okay, A complement, would be the probability that it's not exactly 2 heads, okay? So there's still 8 different possible things with these heads and tails. Okay, there's still 8 of them. How many of them are not exactly 2 heads? Well, if 3 of them were heads, that means that 5 of them were not heads. Okay, so that would be A complement. Okay, if we go back to the dice. Okay, now in the dice, if I want to find A complement, okay, if 4 of them, out of 36, if 4 of them were a sum of 5, that means there would be 32 that were not. Okay, so that's the idea of the complement. So here's how we can use the complement. Okay, so we have M&Ms here. This is what Mars says they make. 24% of them are blue, 20% are orange, etc. Okay, so first let's talk about a valid probability model. If these are the only colors they produce those 6 different colors, what should all these add up to be? Okay, they should add up to be a sum of 1, okay? Because those are all the different possible outcomes. There's no other outcome, so all these probabilities have to add up to be a sum of 1, okay? What's the probability that you don't get a blue? Okay, well, the probability I get a blue is 24. So the probability of a blue complement, right, okay, is not blue, would be 1 minus 0.24, which would be 76%. Okay? Now, another way to do that is you could just add up all these others. If you add up all these others here, that would also give you 76%. Okay? So if you think about equals, if they all equal 1, if I subtract this one away, I'll be left with all these others here. Okay? The next idea is if events are mutually exclusive. So if I roll this die one time, can it be both a 5 and a 1? Okay, well, kind of if it's on the side, right? No, but that doesn't happen. Okay, so if I roll it one time, it can't both be a 5 and a 1 at the same time, right? If I flip this, it can't be a 1, it can't be a heads and a tails at the same time. Okay, on one spin. Okay, I pick one M&M. It can't be a blue and an orange at the same time. Okay. So mutually exclusive means that there's no common outcomes, and so they never occur together. Okay? So the probability of A and B is 0. So the probability of it being a heads and a tails at the same time is 0%. Okay, now, if it is mutually exclusive, then if I want to find the probability of A or B happening, all I have to do is add those together. So if I want to find the probability of it being a green or an orange, green or orange, all I have to do is add those together. So the probability of because it can't be a green and orange at the same time, right? So they're mutually exclusive. So all I have to do is add those two together, and it'd be 36%. So 36% of the M&Ms are either orange or green. Okay? Here's another example of that. On the AP test in 2015, for statistics, this is the outcomes. So if you get a 5, that's like a really, really good score. 1 is horrible, okay? They consider 3, 4, or 5 passing the AP test, okay? So anyway, find the probability the chosen student scored less than a 3. Okay, so they are mutually exclusive because you can't score a 1 and a 2, right? You get one score or the other, okay? So less than a 3 would be these two. And if you add those two together, you get 0.422. What's the probability they earned a passing score? Okay, a passing score I said was 3, 4, or 5. So if I add those two together, I can add those 3 together, I get this. Or, since I already know this one, I could take 1 minus this, and it gives me this, right? Okay, another way I could find that. So using the complement rule makes it easier for us quite a few times. Okay? So we'll look at this last example together. High cholesterol. Okay, how prevalent is that in people? I know my dad has high cholesterol. Okay, so a person has high cholesterol. If they have 240 or above, they consider that high cholesterol. And if they're 200 to less than 240, then they're borderline high cholesterol. So they're getting there almost. So according to the Heart Association, probability of them having high cholesterol is 16%, and borderline almost high is 29%. Why are they mutually exclusive? Okay, so mutually exclusive means that if I pick a person like my dad, he can't be in both category A and category B. His cholesterol level in his blood is either going to be between 200 and 240, less than 240, or it's going to be greater than 240 or greater. Okay? In plain language, what does event A or B mean? Okay, so if I want to find the probability of A or B, what's the probability that somebody's going to be in this category or this category? What's the probability that if I pick a random person, that they're going to have a cholesterol level of 200 or more? Okay? So I can just add those together. So it'd be what? 45%. Okay? 45% of people have borderline or high cholesterol levels. Okay? part C. Let C be the event the person has chosen is below 200, so just normal or low. So the easiest way to find that would be taking, we already found these together as 45, so 1 minus 45 would be 55%. So less than 200 would be our 55%. Okay, so we learned our basic probability, number of successes over total sample space. Complement rule was the opposite, right? That is 1 minus. And mutually exclusive means events that can't happen together. And we found how to find their probabilities by adding them together for an OR statement.